Welcome to lesson 7.4, overlapping triangles for advanced geometry. So the main idea that we're kind of looking at today with today's lesson is this idea right here that overlapping triangles can be congruent triangles, and we especially want to look at them as possible congruent triangles with using them in proofs. So today the notes are just 3 different proof examples. As I go through them, I'm going to just kind of talk about some different strategies during these processes and things to look for in these proofs. Now you'll notice that a couple of the proofs that we look at later, not this first one here, but examples 2 and 3, the people that wrote the proofs split the given or shifted the given later in the proof just to help you see the process that they went through. When I would do any of your proofs, though, any that you write, you will still want to put your given at the beginning of your proof. So don't put the given later in the proof, even though they do in some of these examples. You'll see later on that I made a note to move it to step 1. So the first thing that I look at in a proof, again, is that idea of what information was given. So in this scenario, they gave us that angle D was congruent to angle B, and segment AM was congruent to segment CM. So I went in and I marked angle D congruent to angle B, and then segment AM congruent to segment CM. Then what I looked at was my final proof statement. Eventually what I'm trying to get to is proving that segment BA is congruent to segment DC. So what I'm looking at, BA and DC, BA being the one running here, and then DC the one running here. So with trying to prove those, what I want to look at is the information I already know, as well as larger overlapping triangles in which if I could prove those congruent, then you could use corresponding parts to prove segment BA congruent to DC. So you'll see in all these proofs that we go through for examples, the final justification in all of these for overlapping triangles is that idea of using corresponding parts of congruent figures. So in these proofs, your second to last step is justifying or establishing the triangle congruence. And then once you've established the triangles are congruent, you can then use corresponding parts of congruent figures. So when I look at this image, what I notice when I'm trying to prove segment BA is congruent to DC, BA and DC are on the larger triangles, triangle BAC and triangle DAC. So what I'm keeping in mind is if I can prove those larger triangles are congruent, then those corresponding sides of BA and DC are also congruent. And what I know is they already gave me angle D and B are congruent of those larger triangles. So I'm going to try to build from there. So the next thing I notice when looking at those larger triangles is the bottom side AC is shared. So AC is congruent to itself for step 2's conclusion. Justification, the reflexive property of congruence. Then what I need to move on to is, well, I have a bottom side and I have an angle. So eventually, looking at those triangles, now I need to either get another side or another angle. So I need to look back at what I knew. I knew AM and CM are congruent. So that makes this small triangle here, AMC, an isosceles triangle. So looking at the two larger triangles, I can prove this angle down here, BAC, and this angle down here, DCA, are congruent because of the isosceles base angles theorem, or MCA and MAC in this case. As I named them, I could have also named them, so I named them MAC, MCA. Could have also named them DA or BAC and then DCA. Same thing, same angle, just using a different point along that segment. So establish those two angles are congruent. Then I have an angle, and a side down here, AC, for the larger triangles. So I can use angle, angle, side to prove triangle BAC is congruent to triangle DCA. Now, because I named it BAC, the order of this one would have to be DCA to match up corresponding parts. Once I've finished writing the triangle congruence, then I can prove our proof statement here that segment BA is congruent to DC using corresponding parts of congruent figures theorem. So again, once you've proven the triangles are congruent, then you can say any of the corresponding parts are congruent. So moving to example 2, again, obviously we have overlapping triangles here, quite a few depending how you look at it. So to help us know how to look at these triangles and to break it down is we want to look at the given and the eventual prove. So in my given, I knew angles 3 and 4 were congruent. So right away I marked 3 and 4 are congruent. And I knew angle JLN was congruent to angle KLM. So JLN being the one up here, and then KLN being the one right here. So what they did in this case, I do not agree with, but they laid it out this way to try to make it make more sense logically and in process for you. Again, I would take steps 3 and 6 where they split the givens, and I would just combine those at the top for step 1. So it's fine the way they did this, but again, mathematically, what's normally the accepted practice is you always want to at least begin with part of your given. It's okay to split it, but step 1 technically should be a given as far as justification. But in this case, they laid it out differently just so you could see their line of thought. So again, what we want to think about is looking at this prove. We have segment JL and segment KL. So JL and KL are these outer segments. So eventually I know I will need to use triangles that involve these outer segments. From there, I'm still not sure, so I need to dive deeper into my information. So what they established were 1 and 3 are a linear pair, and angles 2 and 4 are a linear pair. Definition of a linear pair. Based on the linear pair theorem, that's the justification for 2, we could then say angles 1 and 3 are supplementary, as well as 2 and 4. So why that matters is once we've established a linear pair and supplementary, we can then later establish congruency among supplementary angles. So this is where they start to look at that idea. If we know angles 3 and 4 are congruent, then we can also say angles 1 and 2 are congruent because supplements of congruent angles are congruent. So the reason they moved the given down was to pair those two together so that you could see once we had those supplementary angles, then we know that their supplements are also congruent. Then the next part they established segment LN was congruent to segment LM. This would be the converse of the isosceles base angle theorem, because if we look up here, we then have an isosceles triangle in this case, based on the fact that these two angles are congruent. So we can say these two segments are then congruent based on the converse of the isosceles base angle theorem. Now that gave us angles 3 and 4 in this case, 1 and 2, Ln and Lm. We also know from the given that JLN was congruent to segment or angle KLM. So then we could use angle side angle to establish that triangle JLN was congruent to triangle KLM. So JLN being the one outlined here in pink, and KLM being the one outlined here in green. And we can use the angle side angle from those 3 previous steps. Once we've established the congruent triangles, then our last justification to say segment JL is congruent to KL is again the CPCF, corresponding parts of congruent figures theorem. And our last example for today, example 3, they established that segment DB was congruent to segment EB, and that segment AD was congruent to segment CE. They would like us to prove that angle A was congruent to angle C. So again, right away, I go into the drawing and I mark what I know. So I know DB was congruent to BE, and then AD was congruent to EC. The second part established angle ABE was congruent to angle CBD. That would be the same thing as saying angle ABC was congruent to angle CBA. So they just named the same angle using 3 different points. Either way, that is still the reflexive property. Because it's the same angle, it's just named differently. So any segment or any angle is always congruent to itself is reflexive property. They just use different letters to name the same angle because of the way that they're later going to break it looking at the triangles. But either way, it's referring to this angle B right up here at the top is congruent to itself. Then they separated the given, so AD was congruent to CE. Then, based on the segment congruence theorem, anything that is congruent is also equal. So we could say, as they did, the distance AD was equal to CE and DB equal to EB. That allows us to use the additive property of equality, which is if we take AD and DB and add them together, they would equal CE plus EB. So in this case, the larger segment AB, this whole side, is congruent to the larger segment CE, this whole side. Then once we've said they're equal, we can use segment congruence theorem to say that they are congruent. If they are equal, they are congruent. Then we can use side angle side using our given step 1, step 2, and step 6 in this case to say that triangles ABE and triangles CBD are congruent. Once we've established the congruent triangles, then we can say angle A is congruent to angle C using the corresponding parts of congruent figures theorem.